Hi, this is Ryan Gates, and this is my revision of my presentation for the second lab, and I used eScience Lab Kit pictured here, and the eScience was a kit that I received at iNACOL, and the lab that I chose was the Chemistry of Life Lab number 5, which was pH of the household items and how surface area affects diffusion in cells. The repeatability of this lab is a concern. As you can see, the nutrient agar that I am currently using, it calls for 40 milliliters, and that is the agar, all the agar that it gives you right here. It is more than 40 meters, so that they say that it can account for mistakes. However, if you do make a major mistake, I did not measure out completely, but I do not think that there is 80 milliliters within that bottle. There could be, but the repeatability does not seem to be there in terms of if you make a crucial mistake. It took me 30 minutes to complete this lab. As you can see, it tests the pH of household items, and so those are the household items plus the 2 that were given to me in the lab that I tested. The testing did not take very long with the pH strips. The next thing was to take the 40 milliliters of nutrient agar and solidify that. The directions say that it takes 24 hours for it to solidify. My 30 minutes is just actual activity time. I did wait the requisite 24 hours, but I did not account for that in how long it took me to complete the lab. And again, here this is adding the bromethyl blue and the color after addition of bisodium carbonate and the bromethyl blue. I would assume that the students would take just as long as I did. It's not a very skill-intense lab, or it does not require a lot of laboratory skill, and therefore I think if a student follows the directions, they would get it done in 30 minutes. At the most, I would say 45-50 minutes at the high end of the slower moving students, and that's in terms of time-wise, that's what I think. This activity was the exact same as those activities done in a traditional setting. As you can see from this EduBlog, this particular teacher wanted to have their students do the exact same lab that I just did, which is testing the pH level of household items to see that, generally what we tend to drink and cook with tend to be acids, and what we clean with tend to be strong bases and alkaline substances. As you can see, it's set up the exact same. We just take directly from the materials from our house and then test it with the pH strips provided and go from there. The surface lab was not something that I have done before in a traditional setting, and so that was new to me. But the way they've done it with the nutrient agar, it's very easy to see that in a traditional setting that this would be the setup the same, and it would be the exact same in a traditional setting as in at the home. I did not have any technical issues with this lab, no material issues, no other really obstacles other than the 24-hour wait period. I probably could have cut that down to about a half hour of wait period, knowing that nutrient agar solidifies really quickly once placed in the refrigerator, which was what I did. But I followed directions, to get a full student experience while looking at this from the teacher eyes, and so I went the 24 hours. But no issues whatsoever with these, other than the enormity of all the kits that were, or labs that were in the kit, which was just finding the kit. The work product that I would use would be the questions that are assigned, which I'll go over in a little bit when I go through my teacher experience overview. I would also assign a lab report with this kind of template, with the hypothesis, the materials, the procedure, and the results that were given, and then in the conclusion have them answer the questions. As I'll discuss later, I would give supplemental questions to test the knowledge, or use this as a pre-assessment, kind of a pre-assessment lab to see if they can do it, and then build off of the information given in this lab. But definitely a lab report, and to continually do lab reports, I think, is a skill that is needed for all science students. For the overview of the teacher experience, I wanted to focus first on the kit and the setup and the way everything was within the kit. As you can see here, this is a biology kit that I won for traditional biology, online biology class, and it is very overwhelming. If I was a student and I received this in conjunction with an online lab, I would look at this and wonder what all this stuff was for. There is a packing slip that lists all the materials in there. You're supposed to pull out and look for all the materials, and they provide a CD, and that is all that's there. Each of the labs are labeled with the information as to what is in the individual baggies. But overwhelmingly, it's just very overwhelming looking at this picture. I hope you can see that it's just, when you open the kit, it just overloads the eyes as to what's in there. What I did like about the kit, though, is they did have a safety box, because a lot of kitchen labs, they do not have safety kits with them. Obviously, some do address safety, some don't. But I like that they addressed it right away, and they gave you gloves, apron, spill kit, and glasses. And I really liked that portion of the kit that was given to me. On the CD that was given to you, there was the lab manual for this particular kit. The lab manual, as you can see, is 328 pages long, and that's for every lab in the kit. As you can see, there are, excuse me, sorry about this, just went one past it, 28 individual labs. It does give a recommended time, but 28 labs for 328 pages. Again, it's not broken up. As you can see, there is no link here. None of the labs have links. And so to find lab 20, I am technologically savvy, and I know to hit Control F and to find lab 20, and I can search for it, and then I can go to it. My students, not all of them, know that there is a find function in almost any program and on any browser. So finding lab 20, they don't know to go to page 223 of this particular Adobe PDF document. So that is, that combined with the overwhelming nature of the kit itself probably puts a lot of students off when they try and start working on the labs, especially if they're out of order. If the curriculum doesn't follow the lab setup with, kingdoms, life, plant kingdom, all those things right in the same order, it doesn't bode well for student success. Again, being tech savvy, allowed me to separate the lab manuals that I needed for this particular lab, And as you can see, there's quite a bit of space before you get into what the concepts to explore. Introduction. The introduction is a pretty easy read, but I found that the introduction does not have enough information to be able to answer the questions after the lab, after the labs. For instance, it talks about subatomic particles here, which is not necessary to the pH lab itself, like electrons and protons and neutrons. How does that have to deal with pH when we're talking about hydrogen ions and hydroxide ions? That just doesn't seem to fit for me. The chemistry of life, it starts talking about bonding, chemical bonds, nucleic acid, macromolecules, those type of things, and then it starts talking about chemical reactions, and lastly it starts talking about hydronium ion bases dissociate with water, those kind of things. It gets into this paragraph right here, and then that's all it talks about in terms of pH. And then this paragraph right here is all that they mention in terms of surface area and diffusion, and it just asks a question, and then it says one important area is the surface area to volume ratio, and then in subsequent labs we'll learn more about it, and that's it. It talks about needs for nutrient, oxygen needs to diffuse across, and everything. And so that is the background information, which was lacking in my opinion. Here's the first experiment where it says what household substances are acid or basic, and it asks you to give the substance, pH guess, pH paper, what the pH paper said. I like that they have you give the guess and then the paper, write down the paper, because I think having the student give their opinion goes through the scientific process, because you're going with the observation, hypothesis, questions, all those kind of things before actually testing your hypothesis. And I wish they would probably do more than 1, 2, 3, 4. I could see doing 6 or 7 on top of the 2, or at least 10, so 8 more to get a really good data, and also to get them used to using pH paper and testing and guessing and all those types of things. One thing I don't like is that the procedure is after the data table. I wish that would come opposite, so I wish procedure would come first, then data table, because the students might just start filling in the data table, especially since there is a page break, so they may not scroll down all the way. The questions themselves are lacking. Compare and contrast acids and bases in terms of H plus and OH minus. Again, that goes back to the background information, and that really, it briefly covers it, and if a student doesn't read that clearly or doesn't understand that, they will have trouble answering this question. Number 2, that's it. They have 2 questions. Name 2 acids and bases you often use. That's it. Now, if they tested only the 6 that they have that required to test, and they don't know what bisodium carbonate is, they may only have 5 opportunities to get 2 acids and 2 bases out of that. They may not have that data to be able to answer that question right away. They'll probably have to go out to an outside source and Google common household acids and common household bases to be able to get that answer. In experiment 2, I do like that the procedure comes before the data table listed here. Again, they only have you do 3 after you cut the cube into 1 by 1 by 1 and 2 by 2 by 2 and 1 by 1 by 6, and then measuring this, you calculating the surface area, calculating the volume, then calculating the ratio of surface area to volume, and then looking at the distance of diffusion, which comes from using the bisodium carbonate and the bromethyl blue. Again, 3 questions, that's it, 3, and very lacking again in that regard. Looking at my understanding by design, I would think that the content standards that this addresses is how atomic structure is related to properties of elements. In terms, I looked at it in terms of ions and those kind of things. It's a stretch. It really does not address a content standard for the state of Oregon. That's the first experiment. And the second experiment is compare and contrast 4 types of molecules. I did that because I felt that it mentioned the 4 macromolecules in the background information, and that's what I thought. Thank you for listening to this presentation.